Welcome everyone. In this video I'm going to show you my cloud chamber project, and as you could see in my previous video, I have already started to build my own cloud chamber, and I started to build it based on some off-the-shelf parts, but then I had some issues with those things, so I decided to redesign the whole thing and take a different approach and build everything from scratch. So without being condescending or boastful, I would like to say that I think that this is one of the best cloud chamber projects out there. And I can justify why I say this. I would not say this if I would not be confident. So I checked several makers with very popular videos, but they don't really know how Peltier coolers work. So they cannot really make a proper cloud chamber. And then other makers also make beautiful cloud chambers, but they use compressors, and they are very difficult to work with because you need special tools. You need to be able to braze or solder those copper wires, and you need harmful chemicals and other devices which are hard to source or hard to own. So if you don't have a HVAC business or something, then it might be difficult to source those things. But this project is relatively easy to replicate. I documented it, let's say, extremely detailed on my website. So please check the link in the description and go to my website, because then you will see basically step by step how to build this. And it works. So that's also quite nice, because I saw other creators struggling with their cloud chamber, and they also kind of cheated by reaching low temperatures on the hot side of the Peltier cooler by cooling it with pre-cooled water or cooling fluid. So that's not how you should work with these things. And also, one of the unique things of this device that it has a huge surface area. So the surface area right there is 20 by 20 centimeters. So it's an extremely large area, because most of the makers out there who build their own cloud chamber, they typically use a very small, let's say 5 by 5 or 8 by 8 centimeter surface area. But this is 20 by 20 centimeters, and it works on its full area. So I think that that's quite nice and quite unique as compared to other Peltier cooler based cloud chambers. So I hope that you will stay with me and you will see how this whole thing works, because I will explain everything step by step. So we can start with the chamber itself, because that was one of the most difficult part to source, and I actually kind of based the rest of the things on this chamber. So this chamber is just simply a fish tank. It's glass, it's not acrylic, and the reason why I picked glass is because it is resistant to isopropyl alcohol, which I will use inside the chamber to create the supersaturated vapor. So that's a big plus. And then the dimensions of this chamber is very simple. So in all directions it's 25 centimeters. So then that was a relatively easy dimension, and it's a relatively large dimension, so it's nice to work with. If I could choose, I would cut this in half maybe to make the wall chamber lower, because it's unnecessarily high. But maybe on the positive side of the height of this, it's not necessarily a disadvantage, is that I can more easily create a large temperature gradient across the chamber, which I actually need to be able to create a supersaturated layer of isopropyl alcohol at the bottom of the chamber. So it's both a plus and a minus regarding pros and cons of this height of the chamber. So then that's that. The only thing that we have in the chamber is that, as you can see, I put some felt at the top of it. So the bottom of the fish tank, but the top of the chamber, and I simply used a few pieces of magnets and I just clamped them at the top with the magnets. And I have to emphasize that it's extremely important to use a lot of isopropyl alcohol. it's not enough to use just a few drops, but you will need for this specific setup that I use here, this volume, about 30 to 50 milliliters, so almost half a deciliter isopropyl alcohol, because actually this is a very large volume and you need to evaporate a lot of alcohol to be able to get the supersaturated layer at the bottom of the chamber. So then I think I discussed everything about the chamber itself, so we can move to the bottom. So the bottom is actually built entirely in a custom way. So previously I used a off-the-shelf Peltier cooler cooling plate, but that had some weird dimensions, something like 18 by 21 centimeters. So it was hard to find anything chamber related stuff which fits this thing because of these weird dimensions. So then I decided to buy a off-the-shelf plate, 20 by 20 centimeters and 4 millimeter thick aluminum plate. So then I took this plate and carefully marked it based on the arrangement of the Peltier coolers on that off-the-shelf cooling plate. And then after marking, I drilled out the hole for the clamping of the Peltier cooler, and then I also cut threads into them, M4 threads. And I use this because these threads will be used to clamp down the Peltier coolers and the water cooling blocks on the back of this cold plate. So then that's that. And after I drilled the holes, I added some insulation to this. So first I used this kind of insulation, which is just simply a thick foam, and its other side it's a self-adhesive layer, so I could stick this at the bottom of the cold plate. And I also added some let's say frames, which are just some very dense foams specifically made for Peltier coolers, and this makes it easy to align the Peltier coolers properly. So then after doing those things, I added the water cooling blocks. So those are quite long, 16 centimeter long and 4 centimeter wide blocks, and each block covers 2 Peltier coolers, and then it has its own water cooling loop, which I will explain very soon. And then I clamped down this block with some metal braces, and I put some felt pads between the back of the water cooling block and the metal brace. And I also added some nylon washers between the bolt that I use for clamping and this metal brace. So I try to minimize the heat transfer towards the cold plate for all the different kind of possibilities. Because then if the bolt gets, let's say, warm, then the heat can go from the bolt towards the cold plate, and that can have a detrimental effect on the cooling performance. And we need all the cooling performance that we can get, because it's a large surface area and a large volume to keep cold. So then after I assembled this frame, then I put the insulation and everything together, and then on the top side of the cold plate, which will be actually inside the chamber, I applied a special foil. This is, as you can see, a matte color foil, and actually I just bought this from the local hardware store, and this is actually used for the front light of the cars. So this is some kind of tinted foil used on the front lights to make it more dim. And here it is perfect because it also keeps the foam, the skirt which I made around the cold plate, but it also provides a dark background, and most importantly, it is resistant to the isopropyl alcohol. And that's very good because if you remember my previous experiment, I painted the surface of the aluminum plate with some spray paint, And that turned out to be a stupid idea, of course, because the alcohol just simply started to dissolve the paint layer. So now this is fully avoided. So then that makes the wall plate ready. So then I created a frame out of this, which is made specifically for this fish tank and chamber. So it consists of two parts. One of the, let's say, top part, and that only holds the chamber. I 3D printed some corner pieces which slightly protrude towards the cold plate, and they are just thick enough or wide enough to hold the chamber. And then the bottom part is just a bigger frame which holds the rest of the things. And then I just started to wire up everything and do the plumbing. So let's first discuss the plumbing. So now we are looking at the majority of the cooling. So let me explain what happens here, starting from the pump. So the pump takes the water at this inlet, and this is just a simple submersible pump, but you can use it in this way as well. It's totally fine. So the water goes in this inlet, and then it is pushed up from this outlet. So then it goes up to the radiator, and this is a simple, cheap computer part. It's 24 centimeters high and 12 centimeters wide, so it can accommodate two 12 by 12 centimeter fans. And these are those fans. They are actually quite fancy ones. They were rather expensive. It's from Arctic Cooling and P12 Max. They have quite high static pressure, so they are ideal for this kind of cooling scenario. So then the water comes back on this pipe, and then it goes straight under this frame because it goes inside the water cooling block. And after going through the water cooling block, it exists through the other tube, and then it goes inside this acrylic water tank. And then the circle or the loop starts over. So the water gets pumped out here, goes into the pump, goes up, goes through the radiator, the water cools down, and then the cooled down water comes back, goes back to the water cooling block to take care of the Peltier coolers. And I have two identical systems of this. So each pair of Peltier coolers is cooled by one side. So you can see that in the background there is another pump and another acrylic tank and another radiator. And regarding the Peltier coolers, this is what I use. You probably saw it when I did the assembly. But this is the TEC2 19006 unit. This is a stacked or cascade Peltier cooler. So you can see that it looks like as two Peltier coolers were sandwiched together. And in fact, it is two Peltier coolers sandwiched together. But the advantage of this is that we only have one pair of cables coming out here instead of having two pairs of cables when you stack two individual Peltier coolers together. So then, due to this cascading, we have the advantage of producing much higher temperature gradient between the cold side, this guy with the text, and the hot side. And basically that gives the advantage of this chamber, and that's why it works better than the others out on the internet, because of this guy. And the advantage of this is that inside this ceramic sandwich, the semiconductor building blocks are made in such a way that they are already wired to accept the voltage or the input power in a certain way. And what I try to say here is that if you use two individual Peltier coolers, then you have to be careful how you power them. The bottom Peltier cooler is typically taking higher power, and the top one is taking less power because you don't want to overheat the bottom Peltier cooler, because they have very low capacity when it comes to heat transfer. But this is made in a way that you just need one pair of cables, so one power supply, instead of two individual power supplies, because you obviously cannot power two individual stacked Peltier coolers with the same power supply. So then that's the advantage of this. So as I mentioned the power supply, and I already explained how the plumbing works, then let's talk about how the power is supplied. And once again, please visit my website, because everything is explained there. Very detailed numbers, drawings, information, pictures, everything. So please go to my website. Link is in the description. So the main power comes from a similar power supply, and the power supply, which is somewhere inside that big mess under the chamber, is a 24 volts and 16.7 amperes unit, so it's 400 watts. And then the output of the power supply, so these terminals here, are split into three parts. I have two of these guys, SZBK07 300 watt DC-DC converter, and I set them up with the CV and CC potentiometers in a way that they provide roughly 12.5 volts to each pair, because I connected the Peltier coolers in pairs. So two Peltier coolers are powered from one of these. So I have two of these because each Peltier cooler pair receives its power from one of these. And then there is a third unit, which is a smaller DC-DC converter. I don't remember its type, but this is slightly less powerful than the other. And what this does is that it runs the fan, it runs the LED strip, it runs the two water pumps, and it runs the four high-performance fans. And then everything runs properly. And between the output of these other DC-DC converters and the Peltier coolers under the cold plate, you can see those two power meters. It's this guy from a bit closer perspective. So this is my own custom designed DC power meter. It's a high precision power meter, and it's also high power. You can maximum measure 20 amps with it. And each Peltier cooler line is monitored with this power meter. So I can see what is the current and what is the voltage reaching the Peltier coolers. Because actually Peltier coolers should not be run at their highest nominal voltage. Many people out there on the internet, even quite popular content creators, just simply don't know this. And you have to know this, because if you run your Peltier cooler at too high power, then the Joule heating will overpower the Peltier cooling, and you will just simply heat up your Peltier cooler device. And that is obviously not good, because then you lose the cooling performance. So then instead of running it at its maximum nominal power, I run it at a slightly lower power. So then everything works properly. So then basically this is all about the system that I wanted to explain. So now what we need to do is that I obviously have to prove you that this thing works, and we will make some nice pictures and footage and videos here. So then now I will soak those felt pieces with some isopropyl alcohol, and then I have a few spicy stones, for example this guy here. And I will put it inside the chamber, so we will have a nice radiation source, and we will see what kind of traces we get. And I will monitor the parameters and measure the time and so on, so we can kind of benchmark the system, what it is capable of, and so on and so on. So there is the little spicy rock, and then everything is basically assembled. I put a lot of isopropyl alcohol on the felt. So now I just have to plug in the power supply and start it. So now it's started. It's relatively noisy, but hopefully you can see all the details. So while the chamber is getting cold, I just show you some cool details. So what we can see here is the two power meters. You can see that one of the rail is taking roughly 140 watts at let's say 12.9 volts and 10.8 amps, and then the other rail also takes similar, so 132 watts, 12.6 volts and 10.4 amps. So they are roughly the same. And then we have this fan here. This is just blowing cold air towards the DC-DC converters because they tend to get hot. So I had to take care of it somehow. Then here is the little cooling system. As you can see, it works relatively nicely. So as I said, here the water at the bottom outlet goes towards the pump. It goes up, goes through the cooler for the Peltier cooler, and then it comes back, and you can see that it flows back to the acrylic tank. So that's that. So I switched to another camera, and as you can see, the natural background radiation and the radiation from the mineral is already doing its job. So we can see everything, yeah, very nicely. We just saw a very nice decay there and another there. But yeah, you can see that the chamber is super active, and it's active throughout its wall surface. So it's not just where the Peltier coolers are placed under the other side of the plate, but yeah, you can see it's the wall surface. Wherever you look, you will see traces of particles. So yeah, that's really nice. And even without a high voltage grid, I can have very spectacular traces, as you can see. And as I probably mentioned in the beginning, one of the key points is that we need a lot of isopropyl alcohol. So when you recreate this project and you make your own version, don't be frugal. Use half a deciliter, even maybe 1 deciliter of isopropyl alcohol, and use it with a felt or a sponge or anything which can absorb a lot of liquid, because that is the key to actually create enough vapor in the chamber, so the bottom of the chamber will become super saturated, and then you will be able to see this nice spectacular show that I'm now witnessing together with you here. So yeah, you can see that this is very nice, and I'm almost 100% convinced that if I add that high voltage grid to my chamber, then I can get also better results. So of course the next step in this project will be to add it. So as soon as I can get my hands on some high voltage source, I will build a grid and I will add it to the system. But as you can see now, even without that, I can have a rather spectacular show here. So as you can see, the chamber works very well. It produces very nice traces, and yeah, it puts a very nice show here. So if you want to see the components and everything, please check my website. Link is in the description. I put all the resources in my article. I took a lot of time to write everything, collect the parts and everything. So I put links to each parts and everything. So please visit my website because it's full of valuable resources. And please don't forget to subscribe to my channel, because I often see that 90% of my viewers of my videos are typically not subscribed to my channel. And even if one video would attract, let's say, 50% of the subscribers, I could get 1,000 or 2,000 more subscribers at a time, which would be, yeah, nice. So yeah, I hope you like my Peltier cooler based cloud chamber. And if you have any questions, please put it in the comment section, or you can drop me an email if it's a more serious question or inquiry or something like that. So I hope you found this video useful. I hope you learned something, and see you in the next video.